Hi folks, so short video on properties of ionic substances. So what do I mean by properties? So we're looking at the melting point, boiling point, and whether they conduct electricity. So firstly, we should probably answer, what's an ionic substance? So an ionic substance, if you let me draw a fantastically detailed drawing of the periodic table here. So we've got aluminium is our top step. So we've got metals over this side. And then that means this part is the non-metals. And an ionic substance is when you have a metal and a non-metal. General rule of thumb, metals have got too many electrons. Non-metals haven't got enough. So metals are losers. The metals lose electrons and give them to the non-metals. So, because you've got things that are giving electrons away and then gaining electrons, if you lose an electron, you've got to remember electrons have a negative charge. So that means when the metals lose electrons, they become positive, and then the non-metals gain electrons and they become negative. So they are ions. Ions are things that have a charge. We've got positive ions, negative ions. And then the positives and negative ions, because they are oppositely charged, they are attracted to each other. And that force has a name that is called electrostatic force. Electrostatic force. Electro, because it's about charges. Static, like a static caravan. Static means, or if you're static, you're not moving. So charges that aren't moving, positive and negative charge, the charges stay where they are and they're attracted together. And what an ionic substance looks like is this. So this is a model of sodium chloride, NaCl. The green ions are the chloride ions, they're the negatives, and the grey ones are the sodium ones, so they're the positive. And if you look the way it's set out, you've got negative, positive, negative, positive, negative, positive. The way it's arranged, if I pull one out so you can kind of see, in the middle there's a grey one. They're set out so the positives are surrounded by negatives and the negatives are surrounded by positives. And the reason they are set out like that is because of this electrostatic force, this force between the opposite charges. So if we look here, if I wanted to break this apart, if I wanted to pull this one out, pull this negative out, it's actually this negative ion is next to 1, 2, 3, and the one in the middle, 4 positives. It's surrounded by positives. So there's a whole whacking great massive load of electrostatic forces there, which makes it quite difficult to pull apart. So that means, going back to the whole point of this video, in terms of the boiling point and the melting point, ionic compounds have incredibly high boiling and melting points because they're held together by this incredibly strong electrostatic force. What is an electrostatic force? It's a force between oppositely charged ions. So stick it in a sentence. Ionic compounds have incredibly high boiling and melting points because they're held together by strong electrostatic forces between oppositely charged ions. And I'll write that out. So ionic compounds have high boiling and melting points due to strong electrostatic forces between oppositely charged ions. So you've got your positive ions, they've lost electrons, negative ions, they've gained electrons, and then they're oppositely charged, so they're attracted together. And the way that ionic compounds are set out in a giant lattice, which is a key word that you need to know, they're arranged in a giant lattice, and it means all of the negatives are surrounded by positives, or all of the positives are surrounded by negatives. So it's incredibly difficult to pull it apart because those electrostatic forces are so strong. So electrostatic forces between oppositely charged ions. So if we go back to, so that means the first 2 points, the explanation for those is exactly the same, and we've covered that. Both high due to the strong electrostatic forces between oppositely charged ions. It's worth just rehearsing that sentence and getting that sentence committed to memory. So the last point, do they conduct electricity? And I recommend you go and watch the properties of covalent compounds video, because then I explain what conduction of electricity actually is. So I won't do the full introduction into it in this video, but to conduct electricity, electricity is a flow of charge. Flow, fancy word meaning movement. So we need charges that can move. Here's our ionic compound. Do we have charges? We've got loads of them. Every single negative here, every single green is a negative ion. Every single grey is a positive ion. We've got loads and loads of charge, but it can't move because it's stuck in the lattice. They cannot be pulled apart. They don't move apart. So when ionic compounds are solid, they do not conduct electricity. If you do put in loads and loads of energy to overcome that electrostatic force and you melted it, so I'm just going to pull it apart a little bit here. So you did manage to melt it. That means all of a sudden you've got charges that are then free to move. So if you had your battery with a positive wire, negative wire, and then you dipped your wires into a beaker and you filled the beaker with this molten sodium chloride, then that would mean, so this one would be negative, that would be positive. That would mean the charges, because this is a liquid and they're all free to move around, as soon as you turn the switch and turn the battery on, all of these negative ions will move over this way, and all the positive ions will move over this way, because the positives are attracted to the negative and negatives attract to the positive. So the ions can move. Ions, remember, have a charge. So if ions are moving, it means charge is moving, and if charge is moving, it means it conducts electricity. So do ionic compounds conduct electricity? When they're solid, they do not, because the ions cannot move. But if you melt them so that they are molten, then they do conduct electricity, because it means the charges are free to move. It's nothing to do with electrons. Most really common mistake is ionic compounds can conduct electricity when molten because the electrons have got space to flow. It's nonsense. Why can they conduct electricity when they're molten? It's the actual ions that can move. When they're in the lattice, the ions cannot move because they're fixed together. When you melt them and you break all them apart, they're free to move, so all the positives can flow one way and all the negatives can flow the other. And it's exactly the same thing if they're not when they're just molten, but if they are in solution, which means they're dissolved in something. So they do conduct electricity when they're in a solution, because it's for the same reason they do when they're molten. So if you had sodium chloride, sodium's a metal, chlorine's a non-metal, so sodium chloride is an ionic substance, that's what I've been talking about. When it's solid, it does not conduct electricity. So and sodium chloride is table salt, that white crystal stuff that you put on your fish chips. Solid sodium chloride salt will not conduct electricity. If you heat it up to 2000 degrees or whatever the melting point is, it will conduct electricity when it's molten. If you dissolve it in water, it will conduct electricity because the ions are free to flow around. Pure water with nothing dissolved in it will not conduct electricity because it's a covalent substance, and you need to go and watch the covalent video for explanation of that. But if you have water with any ionic thing dissolved in it, so chuck a pinch of salt in water and then it will conduct electricity, not because of the water, but because of the salt has got ions in it which can move. Hopefully that clears that up. Have an average day.